going to get started here. This is Daniel, our Tech Talk speaker. My name is Lindsay. I work here at the Tech Academy. If you guys are students, welcome. And if you guys are not students, you've maybe seen the outreach surveys. If you could fill those out before you leave today, that would be super helpful. And enjoy.
Hello.
Hello.
So I'm really excited to be here, just to talk a little bit about open source and security, two topics close to my heart. I really, since it's a smaller group, I'd like to just take questions as you have them, and just raise a hand or stop me if there's something you'd like to ask a follow-up about, and I'm happy to do my best. If we have time at the end, I might even have something to demo, so we'll see how this goes. So this is what I really wanted to name this talk, but I didn't. But basically what we're going to talk about today is the ways open source consumption can go terribly wrong and burn down your house, and what you can do to stop that from happening. So a little bit about me. I started my startup journey at Puppet in 2011, where I started kind of as a software development intern and then moved into UX design. And then in 2014, I went over to Sonatype, where I kind of did UX and then product management, and then NPM, where I am today. Been there for 5 months, and I do product management there as well. So how many of you know what Puppet is and what it does? Okay, cool. So Puppet is really cool. So Puppet introduced this idea of infrastructure as code. So it's the idea that if you have 10,000 servers, you really want to think of those servers as cattle or as a herd, and not as individual pets that need to be maintained individually, because it makes it simpler to reason about your infrastructure and also to automate. So Puppet's kind of an automation tool built around this concept of infrastructure as code. And Sonatype is known for the open source software supply chain thinking, which is basically that if you write applications, most of the software in your application is open source. And so knowing what you're pulling in so that you're able to ensure quality in your application and security are really kind of important things to keep in mind as you're choosing what packages to consume. So a lot of this talk is actually based upon stuff that while I was there, we were doing it at Sonatype. And then how many of you know NPM? So NPM is the world's, so NPM, the registry, is the world's largest collection of open source software, which happens to be JavaScript. And NPM is also the name of the command line tool that you use to interact with the registry. So NPM install is the thing that lots of front-end developers do every day. And NPM is also a company. They pay my salary, and they also do work on the registry and the CLI. So all these companies have one thing in common, and that's open source. Open source is cool because it lets us avoid reinventing the wheel, which turns out to be really important because for your garden variety production application, 99% of the code in the application is open source. So the fact that you only have to write 1% of the code in your application to get something of value out the door is a huge time saver. It saves you a couple orders of magnitude effort. And it's even better than that because there's so many people that kind of organize around these big popular projects. You end up with a higher level of quality in individual projects than you would get from just a solo developer working on their own in a closet somewhere. So that 99% of code is really high quality, generally speaking. So yeah, that's open source. But before we can talk about the ways that open source can burn your house down, we need to talk about how open source makes its way into your application today via that software supply chain concept. So if you're a typical developer, you're going to write code, but you're going to intelligently decide what pieces of code that you can actually reuse that other people have written from that open source ecosystem. And when you are doing that, you have to decide where that code is going to come from. So you might choose to pull it from GitHub or from NPM, or choose your language ecosystem registry of choice. But it's going to come from one or more of these package warehouses. And once you've decided where it's coming from, you have to cache it somewhere. So if you're running npm install on the command line, npm is going to cache stuff locally in your file systems by default. But you might also choose to have a repository manager that's spun up in your company's infrastructure, so all of your fellow developers can pull from that registry cache to get the dependencies that you need to build your applications. And once you've built your application, so you've taken your own code and merged it with that open source code, and built it, you're going to probably want to cache those application bundles somewhere so they're all ready to deploy when you need them. So that's kind of how open source makes its way into your application and out into the real world. So let's talk about what can go wrong with this, because there's a lot of kind of scary things to consider. The first is that those public warehouses that I'm talking about back here, those can get infiltrated. And in 2017, Homebrew, the package manager for macOS, got compromised by an operations engineer who found a GitHub API token lying around and got full access to packages that are downloaded 500,000 times per month. And every registry has a similar story to tell of someone who managed to compromise them and get access to these packages that millions of developers are downloading every day. So that's one way things can go horribly wrong when you're using open source software. Another thing that can go wrong is that those public registries sit on infrastructure on the internet, and if any of us know anything about the internet, stuff can go down at any time. And what's worse is that individual packages in those registries can also disappear at any time. So something just disappearing out of the blue is a real problem when you're relying on code that somebody else has written on infrastructure that you're not managing yourself. So NPM is rather infamous for a case around this where leftpad was a package that existed that was basically 3 to 5 lines of code, something very simple. But unfortunately, half the internet depended upon this package, which its developer decided to unpublish. So half the internet broke because of this one developer choosing to take their package off the public registry. So NPM, the registry didn't go down, but a package disappeared and broke a lot of things. The third thing that can happen when you're using open source is this concept called typo squatting. So how many of you know what typo squatting is? So typo squatting is a really nefarious attack vector because open source is built around kind of a web of trust. And what I mean by web of trust is, if any of you have read the Cathedral and Bazaar, it's a book about open source and how kind of the movement came to be and what the benefits of it are. And one thing it talks about is the fact that the reason why open source works so well is because you have millions of developers who all have their eyes on the same code. And so the more eyes you have on code, the shallower all those bugs become. And you end up in a situation where other people can just blindly trust that the code is of good quality because there's been so many other people looking at it and keeping an eye on it and making sure the issues are dealt with in an appropriate matter of time. So what typo squatting does is an attacker, if they're able to gain access to a namespace, a package name, for example, either by compromising a GitHub token or similar, what they're able to do is they're able to compromise that web of trust and inject their malicious code into this namespace, and other people will just blindly download it because they trust that the namespace is good. And a variant of this is where, let's say that you manage to gain access to a namespace that looks very similar to one that's very popular with maybe just one letter changed. By doing that, if someone mistypes a search, for example, they could end up pulling down that misnamed namespace and getting that malicious attacker's code as well. So this is a way that people manage to social engineer their way into the open source supply chain. So in 2017, back in the early days, the Slovak National Security Office discovered that in the Python public registry, PyPy, there were a handful of malicious typo-squatted packages that were being depended upon by downstream applications. And so this was kind of one of the early realizations of this sort of attack, and it's become much more common sense in all sorts of ecosystems. So the fourth thing that can go wrong when you're using open source is that dependencies can have dependencies. So if you have your package JSON and you have the 12 dependencies that you rely upon, each of those 12 dependencies themselves could have 12 dependencies and so forth. And so in your typical NPM application, you might install it and then realize you've pulled down half of the internet because of this web of dependencies. And NPM is kind of famous for this pattern, as it were, of modularization, where things are generally very tall, very small, very tightly scoped, which is good because it lets you choose only the packages that you need for your application. But because of that very tight scoping, it means that there's kind of a wide, intractable web of dependencies that you can pull in. And the reason why this is a problem is because it makes it really difficult to know what exactly is in your application. It's not enough just to see what's defined in your package.json. You have to understand this whole surface area of transitive dependencies. So the last thing that can happen with open source is that software tends to age. And it ages not in the sense of cosmic rays coming in and flipping bits on disk, but in the sense of the known surface area of problems with code is constantly increasing. So over time, security researchers might find more vulnerabilities in software that was once deemed good, or you might find bugs in software that once was thought to not have bugs. And so the most popular example of this is EQUIFAX, where they relied upon this Java component called struts, and struts had a vulnerability disclosed, and within 3 days, an attacker had taken advantage of that to infiltrate EQUIFAX. And within 3 months later, EQUIFAX still had not upgraded that dependency, and so they got breached again. And so again, it's not that the software is getting older, but what everybody knows about the vulnerabilities in open source is constantly increasing, and so it creates more opportunities for this sort of attack. So that's all really scary stuff, especially if you are writing applications in a sector like finance or an area where you really wouldn't want an attacker messing about with your client's code or infrastructure. But at the same time, like, open source is a great thing. Like, we don't want to have to write that other 99% of code that we don't have to write today. So how do we get the best of both worlds and keep using open source like we want to, but not have it blow up in our faces? So there's kind of 5 things I want to talk through. And this is going to be a fairly high level. I'm more than happy to dive down into some of the details about these things later if you want to talk to me. But this is just kind of intended to give you an overview of the landscape of things to think about as you're pulling in open source. And then, yeah, we can go from there. So the first thing you got to do is when you're choosing where those packages come from, you have to make sure that those warehouses are trusted, that you trust them. The first thing you want to consider is, given all of the languages that you use, there's probably one source of open source packages for that language that's considered to be canonical in the community. So Java has Maven Central, JavaScript has NPM, Python has PyPy, Ruby has RubyGems, .NET has NuGet, and so forth. And these are usually a great place to start because of that many eyeballs makes all bugs shallow idea, where NPM is used by millions and millions of developers, and they have a common interest in making sure that issues get dealt with quickly, malicious packages get pulled down, and so forth. So choosing a more popular source of components is generally just a good place to start for that reason alone. But another thing to ask is, what are the gates in place to ensure a minimum level of quality in a given registry? Now, if you are a Java developer and you use Maven, you probably use Maven Central. And Maven Central is very strict on what packages can be published to that public Java registry. So everything has to have documentation, source code, it has to be signed, it needs coordinates, it needs a project URL, a declared license, a list of developers, and usage examples. And this is really good if you're a consumer, because it means anything you get in Maven Central is going to be at some minimum level of quality. But a lot of registries aren't that way. So like NPM, you don't have to do hardly any of these things, and you can get a package published. So if you're a developer looking to contribute to open source, the barrier to entry is very low, which is good, right? Like, it encourages people to become part of the ecosystem and to contribute. Where it gets tricky is if you're a consumer and you're looking for good packages, if you don't have a lot of gates in place, there's going to be a lot of noise you're going to have to sift through, and that can take a lot of time. But what we're going to talk about next is how you can still ensure quality even if the registry you've chosen doesn't necessarily check all these boxes for every package that's published. So another thing to consider as you decide where to pull packages from is what happens after the package has been published. So there's 2 schools of thought. You have the immutable school of thought, which says that every package, once published, should never be unpublished. It should never go away. And the reason is because you do not want to break downstream builds, like what happened with LeftPad. So that's one way of thinking. The other way of thinking is that packages should remain mutable. So if a package is published that is known to have malicious code in it, then there should be freedom to take it down so that that bad code does not exist in the registry. And that's obviously a good thing as well, but you do run the risk of breaking downstream builds that depend upon that code. So again, this is kind of where you have to weigh the balance between, do I choose a registry that has all these gates and quality barriers baked into the system, or do I use downstream tooling to ensure that what I pull down is good, even if there are bad eggs in that registry? So that's one of the choices that you have to make. And again, this is an area where like Maven Central takes a very strong, we will not break your builds approach, and NPM back in the left pad days was very much, we are okay with breaking your build so long as the stuff in the registry, isn't malicious. So the next thing to consider is if you are a package publisher and you're putting something in this registry, what does the registry do to ensure the security of those packages, right? So if the registry has multi-factor authentication, then it's less likely that you're going to get your tokens compromised and someone's going to break into your account and start publishing stuff under your name. And again, like not all registries have multi-factor authentication, so it's something to keep in mind. So that's all like the registry side of quality, but there's also like this package side of quality. So once you've chosen your registries and you're like choosing packages you want to reuse in your own applications, how do you make sure that those are of an acceptable level of quality? And so the reason why you can't do all this in the registry is because not everything is binary good or bad. And a perfect example of this is licensing. So in open source, there's one big issue with licensing that you have to keep in mind, and that is this concept of a copyleft license. So if you use something like AGPL, if you pull in an AGPL dependency, that's going to legally compel you to release the source code of whatever application you're writing to the public. So if you're working for a company that has a proprietary application, that's probably not something that you want. The problem is, a registry has no idea what the context of your application is, what the legal context is. And so they can't simply say that AGPL stuff is bad and we can't host it here. So that's a decision that you have to make downstream after you've already chosen your registry and are then choosing what packages to download. And so in the proprietary case, a license like MIT is probably much more acceptable to you if you're looking for open source stuff that's not going to compromise your own legal requirements. Another element of quality is vulnerabilities. So at the time I put the slide together a few months ago, that number was a little bit lower, but it's growing at a fairly rapid rate. So there's hundreds of thousands of these security vulnerabilities that each impact many packages. So knowing like which of these impact your packages is really important to know. And again, a reason why you can't just let the registry deal with this is because if you're writing an application that's an internal tool that's not connected to the internet, maybe you're okay if it has a vulnerability so long as an attacker can't access it through your company's infrastructure. So again, this is a decision that you have to make on a case-by-case basis as to whether or not you're willing to accept the risk in your applications and what that risk is. So again, like another question you got to ask when you're pulling down a package is whether the package can prove that it is what it claims to be. So having a package that's signed or having a maintainer with a public key that you can use to verify their identity are all things that are important when you're deciding what you're going to trust that you're pulling down from this registry. And another kind of interesting point around quality is that like how well things are maintained makes a big difference. Because even if something is of high quality, if it doesn't have a community around it, they won't be able to respond as that web of knowledge grows around vulnerabilities or bugs in your package. So, for example, with Linux, I generally trust that the Linux community is going to deal with stuff as it pops up. I'm not going to sweat it too much. Whereas someone who randomly uploaded a Ethernet driver to GitHub and has no commit history around it, I'm going to be a little more skeptical of whether it's going to be good a year from now. So the good news is that you don't have to do this on your own. There's a lot of great resources online to help you understand the quality of the stuff you're pulling down. So purely from the vulnerability side, there's a lot of databases available that give you information about what's good or bad in your packages. So CVE and NVD are two of the more popular ones, but there's a ton available online. So once you've chosen a list of warehouses and you've chosen your packages, the next step is to cache those packages. And let's get into like why that's important. So it's important because the internet is kind of a dumpster fire and can go down at any time. And so having something cached means that you're not reliant upon that upstream infrastructure more than you need to be. But caching is also really important internally because you might have your CI/CD pipeline and CI over here is on fire, but because you've been smart and you have a cache set up for your applications that you built, you can still deploy them at any time. So caching is a really great way of decoupling critical pieces of your infrastructure and helping to localize the extent of outages. But caching is also really important from a performance standpoint. So I'm not saying in this slide that you should put all your packages in L1 cache. That wouldn't make any sense. But what I'm saying is that stuff that sits close to you is generally much faster and cheaper to pull down than stuff that sits a long way away from you. And it's not only faster, but it also helps you to be a good citizen of the internet. And the reason that this is so critical is that the big public registries like NPM, they cost millions of dollars to host, right? And they're free resources that the whole open source community uses. So the more that you cache stuff, the less the less that you're using their bandwidth in hosting, and the easier it is for these companies to continue to offer these free resources to the rest of the community. So caching is a really, really great thing to have. And it turns out there's a lot of ways you can cache. So I mentioned earlier that with like npm install automatically caches stuff to your local file system, and that's a great kind of default baseline. However, there is this concept of a repository manager, which is also a very common way to cache. How many of you have used or heard of repository managers? So a repository manager is a service that serves as a place where dependencies are cached, and it sits between your build infrastructure and the public registry. So there's kind of two main flavors. On the vertical axis, you have repository managers that kind of sit in the cloud. You don't have to spin them up. They're kind of self-service, hosted things. And then on the bottom, you have repository managers that you have to spin up on their own server or on your laptop, and you have to maintain them. And then on the horizontal axis, you have repository managers that are focused on a single ecosystem. So if you are really into JavaScript and you have a node shop, you might just be happy using Verdaccio, which is a very popular JavaScript repository manager. But if you happen to use a lot of languages at your company and you would like a single source of truth of caching for all of those different ecosystems, then you probably want to use something like Nexus Repository Manager or Artifactory to keep all that stuff in one place. So yeah, repository managers are pretty cool. So we've basically decided where the packages are coming from. We are making sure the packages are of good quality. We're caching them, so we're being good citizens of the web and improving the performance of our own CI/CD pipeline. So now we're at the build stage. So when you build a thing, it's a really great idea to bundle it in one place, all those bits. And the reason why you want to do that is related to this software engineering design pattern of encapsulation, where a thing is much easier to reuse if it has a well-defined interface and all those internal bits are kind of hidden from the user. And so how this translates to the topic at hand is that if you have your application bundle with all of its dependencies in a single easy-to-consume blob or Docker container, it's much easier to deploy that thing and understand how to just get it out there for your customers. But the other reason why this is really important is because of this whole concept of versioning and having confidence in the things that you have in your bundle being the same from build to build. So this is a snippet from a package.json file where I've defined 3 dependencies. I have Express, MongoDB, and ASYNC. And you'll notice that for Express, I've said that I want the latest version of Express every time I run my build. So every time I build, I could get a different version of Express, which doesn't give me a lot of confidence in the thing that I'm in this bundle being the same. Like it's going to shift and change every time I run my build. Or you might say, I'm bought into this whole semver thing. I only want the latest version of MongoDB 4 because I'm convinced that as long as I stick to minor version and patch version changes, it's not going to break my application. You might do something like this. But every time you run your build, you still might get a different version of MongoDB, which is a different set of bits. Now, you might say, I'm onto you, and I'm going to say, I want async 2.6.2 every time I run my build. This surely will be the same set of bits every time I run my build. Unfortunately, the answer to that is maybe. And the reason why is because the version is still kind of a leaky abstraction. So there's a couple of ways this can go terribly wrong. The first way is that if you were to run a command that installs a package that has platform-specific binaries, if you run this npm install on Linux versus Windows, it's going to do a build step, and you might end up with a different binary for the same version, depending on your platform. Another way this can go wrong is that if you remember that some registries are mutable, right? So you can install async 2.6.2 and then go away for a while, have a cup of tea, and while you're off doing that, someone unpublishes that module from the registry, publishes a new version with the same version string with a different set of bits, and you come back from tea and run build again, and it's a different set of bits. So that's why like a version string alone isn't really enough to have confidence that what's in that application bundle is consistent and sure to be the same from build to build. Unfortunately, it gets worse than that because of this whole idea of transitive dependencies. So those dependencies in your package.json file each have their own dependencies, and you have no control over the versioning of those dependencies. So even though you might say that you have some semblance of control over that first line of dependencies, you have very little control beyond that. It's kind of throw your hands up in the air and give up. So this is a problem. Now, it might seem a little academic, and so I should probably like bring us down to earth a little bit and explain why bundling really matters from the context of using open source responsibly. And it comes down to this whole idea of scanning. So remember we said that the software tends to age like milk and not like wine. It gets worse over time. It doesn't get better. So the older software is, the more likely it's going to have vulnerabilities and bugs that are discovered in it. So if you have a bundle of software with bits that you know are the same from deploy to deploy, then you can start to like scan that bundle over time and say, here's a threshold of risk beyond which I'm not willing to accept the risk any longer. And as soon as the bits in that bundle cross that threshold, I know that I need to upgrade some dependencies and redeploy this application. And this is really, really important because it means that you start to have visibility and control into the quality of the software that you're deploying. So this is essentially why consistency in versioning and having confidence in what's in your bundle is so important. So that'll make sense, but like how do you do that? Like, what's the process of like scanning the application bundle and getting insight into what's in that blob? So in the olden days, you might use a Google to run a search for each dependency in your application, all 10,000 of them, and for each one, be like, oh, this is what the internet says is good or bad in this package, and so maybe I shouldn't use this package, I should use this one. It's going to take a long time. It's going to be very messy, very high signal or very low signal-to-noise ratio. There are better ways of doing this. So some bright individual said, I'm going to create a vulnerability feed that has only vulnerabilities. So all you have to do is go to my feed, subscribe to it, and whenever a new vulnerability comes through the security research pipeline, you'll get notified of it, and you can see if it impacts your application. So this is much better than a Google search, but it's still kind of a grab bag. Like, it's hard to tell sometimes if a thing really applies to your application or not. It's a lot of information to sift through. So we now have these things called vulnerability databases, and I had that listed them earlier. And these are really cool because they let you do queries. So you can say, given this vulnerability, I want to see all the packages that are affected by this. Or you can flip it and you can say, given this package, I want to see all the vulnerabilities that apply to it. And this gives you much more confidence, a much higher signal to noise ratio as you're doing your research. But it's still kind of manual, and still probably sounds kind of painful. And yes, you can script this, and you can write something that queries a vulnerability database and lets you know whether or not anything applies to your application. But if that sounds kind of like reinventing the wheel, that's because it kind of is. And so it turns out that lots of very smart people who are much smarter than me have written tools that do that automated research and remediation piece where they will not only tell you what's in your application, but they'll also tell you maybe what you can do to fix it, like what dependencies to upgrade to fix it. And the reason why all of that is really important is because the time to first breach after a vulnerability is disclosed is rapidly going towards 0. So if you remember back a ways, when EQUIFAX got breached, that vulnerability got disclosed 3 days before the breach, right? So they had a window of 3 days to fix their problem. And it so happens that they did, but 3 days isn't that much time, and that time is actually becoming hours, because there are now tools like Shodan.io, which let you run a search for popular web services, where you can kind of get the IP addresses of web services and their version. And so if you know what vulnerabilities impact those versions of those services, you can trivially script and automate the process of compromising those services. So attackers have all these tools that they can use to quickly take advantage of any vulnerabilities that are disclosed. And it's actually worse than that. So there was a research paper recently where a researcher wrote a machine learning algorithm that would basically scan Twitter and with 75% accuracy would predict vulnerabilities before they were disclosed on the National Vulnerability Database. So you have attackers with tools now that can help them find vulnerabilities before the experts do. So that time to first breach is actually going below 0. Like it's really kind of grim. So the whole point of this is that automated research and remediation is important because you got to stay ahead of the attackers. And so the more that you use these tools to do this stuff automatically, the less manual effort, but also the faster you can respond to these issues. So I won't let you down. There's a lot of tools that do these sorts of things. Most of these are open source, and they do different ecosystems. Some are JavaScript specific. And NPM actually has this sort of tool built into the command line tool itself, which I'm happy to demo afterwards if we have time. But there are tools that do this sort of thing, and these all kind of use these open source databases I shared earlier. So it's open source tooling built upon open source data, which means there's lots of eyeballs looking at it and keeping it up to date, which is really great. And a lot of security researchers, most security researchers are actually on the good side, so they're actively helping to make these tools better and to make the data better. So yeah. So this has been a talk about process and a talk about tools, but as we all know, it's really not about process and tools in the end. It's about making sure that from a people and a culture perspective, how to make sure that you're set up for success. Because you can tell a developer to use a database or to use a tool, and they will probably look at you and then walk away and shake their head. So it's important to make sure that everyone understands the importance and everyone is bought into this idea that security and quality of open source is really one of the most important things that a company can do beyond delivering something of value to its customers. So how many have read the Checklist Manifesto? Okay, this is a wonderful book. It's actually written by a physician who had this revelation where it turns out that I think it was 80 to 90% of complications after surgery can be tied back to a very small list of things that just aren't done prior to the surgery, like washing your hands. And so when people in an operating room are given a small checklist of things to do prior to a surgery, the rate of complications drops dramatically. So without a lot of fancy tools or equipment, you can achieve an astonishing gain in just quality without that much effort. It's just leaning on humans a little bit more. So the way this relates to software is that there's a lot of things, a lot of low-hanging fruit that a software developer can do when they're choosing packages to consume that would save a lot of grief later on if they were to do them. And so if you give a developer a list some of the things that we've talked about, that can actually have a huge impact without going much further than that. And it can prove the value of, you can prove that it's possible to improve security and quality without actually spending a lot more time on it. But at the end of the day, like, humans don't like really long checklists. So you might have a list of 1,000 things that are provably behind higher quality software, and yet a human's not going to go through a list of 1,000 things every time they want a new package to download. So this is where you actually need tools to help automate those mind-numbing tasks, right? And leave the things to humans that humans are really good at and that machines are not good at. So this is another really great book. One of the authors of Accelerate is Gene Kim, who wrote the Phoenix Project, which is a book about DevOps and kind of how DevOps organizations can really transform a business from a services and infrastructure standpoint. But Accelerate is really cool because it really applies science to this question of what are the qualities of high-performing software organizations. And one thing that they found is that the more frequently you release software, like if you release software frequently, that causes the software to be of higher quality. And it's not simply that there's a correlation between the two. It's actually, they were actually able to prove that organizations that release, dozens of times per day tend to produce software that's of higher quality than organizations that release once a week or once every couple of months. And so this turns out to be really important when we think about this whole tooling and process thing. So if you introduce a lot of tools and processes designed to improve quality and security, but it slows you down, then you're probably not actually getting the outcome that you want. So keeping an eye on like your release cadence and seeing how that changes as you introduce like new tools and processes to improve security and quality is a really important thing to make sure both of those are moving in the right direction. And so I kind of made a reference earlier to like how it's easy to come to an organization as a crusader for security and then get shut down by the organization that doesn't believe in you or believe in your ideas. So it's very important to not think that a security team, often a cubicle somewhere, is all you need to make this problem go away. It really has to be something that all the developers, like all the management layers, everyone believes is important. And if that sounds kind of implausible, it is really hard. Like, it's hard to enact this kind of change in an organization. Organizations are kind of their own, beast in and of themselves. But it is possible. And I've worked at places where this is actually come to pass, where someone's come in with some ideas of how things could be better, and then successfully got the organization to adopt those things. Sometimes it took a long time. And one way that you can do that is through something that this book talks about, which is this idea of complementary innovation. So a complementary innovation is something that raises the value of all things in its shadow. And like the best way to describe this is kind of through an example. So, so Tesla is a company that produces electric cars. And these are great electric cars. But they also produce this thing called the supercharger network. And the supercharger network is a product, essentially, that makes some of the major limitations of electric cars go away. So if you have a supercharger network, then all of a sudden long-distance road trips are possible because it doesn't take 8 hours to recharge your car every 300 miles. A supercharger network also means that if you don't have the right charging infrastructure at home, there's a place to go that's effectively like a gas station where you can fill up and use your electric car. But that's not really what makes it a complementary innovation. Like, each of these things in independent are perfectly fine products. Like, it's a perfectly fine car. If you had a company built around the car, it would make a lot of sense. It's a perfectly fine supercharger network. If you had a company built around charger networks, that would make a lot of sense. And there are actually companies that are built around that model. But what makes it a complementary innovation is because Tesla has actually created integration between these supercharger networks and cars through their software. So if you're driving your Tesla and you're not going to have enough range to get to your destination, the navigational software will say, here's a supercharger network that you can direct to, charge, and then be on your way. And this integration actually makes both the cars more compelling, because now you're going to have less range anxiety, but it also makes the supercharger network more compelling, because you're going to use it more, right? It's going to be more part of your routine. And so the way this translates to software is that, let's say that you are part of a business that delivers some service or product that solves a problem that your customers have. If you do that, then that's great. But if the software isn't of high quality, then those customers are eventually going to run into problems, or your engineering organization is going to be stuck with toil and maintenance and all this unfortunate tech debt. So if you have software that's actually of great quality, and you have a product that's solving a problem that customers have, well, that combination is going to actually raise the value proposition for your company as a whole. And like, the reason why Apple became a $1 trillion company is because they do this really well. Like, they have all these different products and services that all collaborate together to solve problems that individual products couldn't solve. So like, Apple does complementary innovation very well. So the more that your company considers things not in isolation, but as part of a larger whole, the more successful you'll be. And this is one way that you can actually get buy-in in an organization. When you have those little wins, whether it's through basic checklists that show how making small changes, small tweaks to your development process can have a big impact on quality, the more that you can get buy-in from others. So just to summarize, we talked a little bit about picking your trusted source components. We talked about checking for quality issues in those components. We talked about caching and bundling, and then scanning regularly. And then we also talked about culture and people, and how it's important to get the whole organization involved. And that's the end of my talk. So, thank you. So we have a little bit of time. So have any of you used any NPM audit, NPM security tools or anything? Okay. So I can show kind of what that looks like. So NPM, so I've got this project, this node project called JuiceShop. And JuiceShop is a deliberately insecure web application intended for purposes of educating people about security. And so as you might guess, you can run npm install and install it. But you can also run npm audit to get a sense of what security problems there are in that application. So if I run npm audit, it's going to tell me that it found 75 vulnerabilities in this application, and the relative severity of these vulnerabilities. So this is kind of what I mean when I talk about automated research, is you have a tool which can very easily go out and tell you what's in your project without you having to do a lot of manual effort. The other thing you can do is you can do the remediation piece as well. So if I do npm audit fix, what it's going to do is it's going to go out and say, what upgrades could I do to these dependencies to get rid of as many, to upgrade to as many dependencies that don't have any vulnerabilities as possible. So it's going to do some thinking, sometimes a lot of thinking. This is where you find out how good the internet actually is. But it's like, another reason why this is a cool tool is because it's built into the CLI, so you don't actually have to download a separate tool like I showed in that list. You just have this as part of the tool. In fact, if you run npm install by itself, it'll actually give you a summary report at the end of the install. So you don't even have to run npm audit as a separate step. It's just kind of baked into the typical workflow. And so what npm audit fix also does is it realizes that upgrading to a new major version is probably a bad idea because it's going to break more stuff. So it will specifically only look for upgrades that involve bumping the minor version or the patch version of your dependencies. And you'll still want to run tests and make sure that things aren't broken. But it does that just to be a little bit more on the conservative side.
Is it actually installing into the project, or is it going to be like it's going to generate like a list of suggestions for you?
It'll actually change the package.json file and install those upgrades. Yeah. So what you can do is you can, once it's done, it's thing, you can commit that and then publish to GitHub and NPM.
Yeah. Good.
While we're waiting, any other questions on any of this stuff? Or?
So when you're caching packages, I always thought that like the L cache, L103 cache is pretty small. What kind of stuff are you caching in those?
Oh, that was just an example.
Oh, yeah.
It's basically just file system, and then file system caching, and then having that service that runs where you can cache other stuff. But yeah, not in memory or in CPU. Though I guess you could cache stuff in memory if you wanted. Yeah.
I saw that one.
Normally this is like 30 seconds, so probably. But thank you. Yeah, and feel free to try this out. And if you try it and it blows up, feel free to let me know. I'm happy to help. So, thanks.
Thank you.